You guys, so what we're going to be doing today is we are going to learn how to divide radicals, and we're going to learn a really important topic that will be real important for you in grade 12, and it's called rationalizing the denominator. So let's get into some basic questions on dividing radicals. The rules are listed at the top. I do find with these questions, every question has a little bit of a different technique to solve it. So I'm going to try and outline as many as possible. We'll do all the questions on the left. One of the rules is when you have a fraction under a radical sign, you're allowed to split that fraction up and put a radical sign on the numerator and denominator separately. So I can rewrite this question. So it's root 49 over root 100. And then it's pretty easy to solve. It would just be 7 over 10. Okay, so that's one of the rules for quotient rule up here, that you can take a fraction that is under a radical sign, and you can split it up to put the radical in the numerator and denominator. For question 3, we can do that. However, you're going to notice that you're not going to be able to simplify this as nicely. So you'll get root 3 over root 16. And the only thing you can do with this question is have it as root 3 over 4. Because 3 is not a perfect square. Another rule is you're allowed to have a radical in the numerator. However, you're not allowed to have a radical in the denominator. So as soon as we come upon a question where we do have a radical in the denominator, that's when we're going to learn that new rule. But I think this page, we're going to be pretty safe. How about a question like this? Root 10 over 45. There are no perfect squares. However, you can simplify both of these numbers. So I can write root 10 as root 5 times root 2. And I can write 45 as root 5 times root 9. And the benefit of doing so is when you have a radical over another radical that are exactly the same, just like in rational expressions, you're allowed to cross those out. So I can get rid of my root 5s. And all I'd be left with is root 2 over 3 as my final answer. So do you notice how on all 3 examples, we're kind of doing them a little bit differently, but kind of the same as well? Yeah. Can you? Oh, yeah, sure. Oh, I lost everything. Is that better? Okay. Yep. Okay, 96, that is divisible by 3. So I'm going to go ahead and split that up. So it's root 3 times 32. Root 32 over root 3. Now, if you wanted, see how we have 3 times 32 is 96? You can also split up the 32. So if you want to save paper, sometimes what I do is I'll erase the 32, keeping it in mind, and I'll just put in a 16 times 2, because we know 32 simplifies to 16 times 2. So really, 3 times 16 times 2 will give me 96. If that's tricky, though, you can feel free to do it in 2 different steps. That's fine as well. I can go ahead and cross out the 2 root 3s. And I would be left with 4 root 2 as my final answer. If I'm going too fast, you guys let me know. Okay, question number 9. For question number 9, that's actually more of the same stuff. So it'll be 3 root 5 over root 9 times root 5. And I notice I can cross out the 2 root 5s. So I'll actually be left with 3 over 3, which simplifies to give me a whole number 1. To write it like that. Yes, of course. Yeah, which is what happens, when you do 10 divided by 2, you're left with a 5 anyways. So yeah, however you'd like to write it, that's fine. Okay, so this is going to be 10, and we know 48 is 16 times 3 over 2 root 3. So the root 3's can cross out, but also you can simplify coefficients as fractions. So 10 over 2 is the same as 5 over 1. So in this question, we're just going to be left with 5 times root 16, which is going to give us a 20. Okay, now these questions, they were all pretty straightforward because none of the denominators were radicals. But here is where we're going to get into our sort of new rule, and it is rationalizing the denominator. So it says to be fully simplified means there is no radical left in the denominator. Sometimes this can occur with dividing. The process of eliminating the radical is called rationalizing the denominator. To rationalize a denominator, we are going to multiply both the numerator and the denominator by the radical in the denominator, then simplify. This is a really important concept for when you get to calculus in grade 12 as well and advanced functions. So we introduce it here and you're going to hear these words quite often later on. So what exactly does it mean? Well, 4 over root 7 is not allowed. It's not fully simplified. It's actually really poor format. It's kind of like leaving an answer as 5 over 10. What we need to do is we need to get rid of that radical in the denominator. And to do that, we are going to multiply the top and the bottom by whatever the radical is. And this step is called rationalizing the denominator. How come we can do this? Does it change the value of the question? No, because we're multiplying the top and the bottom by the same thing. So really, that's just multiplying it by 1. But what it helps us do is the numerator now will become 4 root 7. And what is root 7 times root 7? Just a 7. So we've just rewritten the exact same question, the original 4 over root 7 in another way. It has the same value though. The value doesn't change, but now we don't have a radical at the bottom, and that's what we're looking for. Just so it's not, actually, no, we can do all of them. That's fine. There's plenty of time. Okay. In question 15, the first thing we should do is try to simplify it because it's not fully simplified. So just like before, I'm going to break it up. So it's root 81 over root 2. That is going to give me 9 over root 2. And unlike before, this answer is not our final answer because it's not fully simplified. So in order to rationalize the denominator, we are going to multiply the top and the bottom by root 2. The numerator will become 9 root 2, and the denominator will become a 2. And that's it. Go ahead and try questions 17 and 19. 21 has an additional step, so we'll do that one together. But you guys go ahead and try 17 and the next one, and I will do it on the screen as well. Oh, question. And remember, before you start rationalizing the denominator, you want to make sure your question is in the simplest form as possible. So for question 19, you should actually simplify it first before you start doing anything else. For question 21, we haven't had a situation where we have had a number with the radical attached to it. And in a case like this, you don't have to actually multiply the 6, you just have to multiply it by the root 2. So when I'm rationalizing the denominator, I'm going to have root 2 over root 2. And then I'm going to keep going. So this will give me 4 root 10 over 6 bracket just a 2. So this will be 4 root 10. I'm running out of space. Maybe I'll just go sideways. You could. If you guys wanted, we could do that as well. 2 over 3. Actually, that's probably easier because now you notice the 2's cross out and your final answer is just going to be root 10 over 3. So thank you for that. That actually made it a lot easier. Sorry. 10 root 3. Okay, the last question on this page is root 3 and then over 2 root 3. So for this question, we can't really do anything. We're going to have to go ahead and multiply by root 8 and root 8. And so this is going to become, instead of multiplying them together, I'm just going to keep them sort of separate just to see what happens. And then we have 2 times 8, which is going to give me 16. Actually, even better, instead of keeping it separate like that, we can actually start to simplify. So I'm going to have root 3 times root 4 times root 2 at the numerator. And then the bottom is going to be 2 over just 16. Then the numerator is going to simplify to give me 2 root 6 over 16. And 2 divided by 16 is just 1 over 8. So my final answer will be root 6 over 8. To simplify, when there's a monomial in the denominator, rationalize by multiplying the numerator and denominator by the radical in the denominator. So the only thing that really differs here is now we have to distribute the radical that we're rationalizing with. In question number 1, we are going to multiply the top and the bottom by root 2 over root 2. And the only thing that changes here is, see how the numerator has a binomial? Well, now when you multiply that root 2, you have to just distribute it to every term inside. So you're basically going to be multiplying it to this term and multiplying it to this term. Okay, so what's that going to look like? 2 times root 2 will just be 2 root 2. Root 5 times root 2 is going to be root 10. And the denominator is going to be root 2 times root 2, which is just a whole number 2. And that's it. Yes. No, the 2's cannot cross out because there's a plus sign now. Yeah, so in order for you to cross anything out, everything has to be multiplied together. Okay, let's skip question 3. Oh no, actually question 3. Oh, question 3 is really good. Let's do question 3. So for question 3, again, we're rationalizing the denominator. We're going to multiply the top and the bottom by root 2. We're going to remember a binomial has to be in brackets. And we're basically going to distribute that root 2 to everything inside of the bracket now. So we're going to end up with 4 root 2. Now look what happens here. We have 6 and then root 2 times root 2. So this is really just going to become 6 times whole number 2, right? Because 2 of a pair makes a whole number over another whole number 2. Okay, keep going. We have 4 root 2 minus 12 over 2. Can I simplify this any further, Sarah? Yeah. So in this case, what you can do is, see in the numerator, we have a 4 and a 12. You can actually take a greatest common factor of 4 and see what you are left with. So let me just write that a little bit smaller. I'm going to factor out a 4, and I'll be left with root 2 minus 3 all over 2. And anytime you have a common factor like that, like coefficients that are factors of each other, you should factor them out, because now what you can do is you can simplify this fraction and your final answer will just be 2 root 2 minus 3. Or you can distribute it and write it as 2 root 2 minus 6. Either or should be okay, yes. All right, let's do question 5. And then do you see the type 2 at the bottom? We're actually not going to be learning that right now, or actually for this unit. So we're going to just ignore all of those questions and you won't be tested on anything like that. It does deal with a conjugate and multiplying the top and the bottom by a conjugate. But like I said, we're not going to talk about that. So last question is question number 5. So you have a choice here. If you wanted, you could simplify the root 12 and make it into 2 root 3. And I think just to be consistent, I am going to do that. So my first step will be 2 minus root 5 over root 4 times 3 is 2 root 3. I'm going to multiply the top and the bottom by root 3. And remember, the binomial at the top is kind of in brackets. So we're going to have 2 root 3 minus root 5 times root 3 is root 15 over 2 times whole number 3 is a 6. Can we simplify this any further? Are there any coefficients that can all simplify? Like, is there a coefficient in every term that could be reduced? The answer is no, so that's actually your final answer. If there was like a number over here, like a 4, a 6, a 8, a 12, or something like that, then you could simplify any further. But if not, that's as far as you can go. Okay, so your homework for this section is, okay, so question number 2, we have root 8 over root 32. So what we're going to do, or what I'm going to do for this question is I am going to go ahead and split this up into root 8 over root 32. And now we're going to take our radicals and we're going to simplify them as much as possible. So root 8 is going to become root 4 times root 2. And root 32 is going to become root 16 over root 2. When you have, just like rational expressions, when you have the same radical at the top and the bottom, you are allowed to cross those out. And so what you would be left with is the square root of 4, which is a 2, and the square root of 16, which is a 4. Can we simplify that any further? We can, and our final answer would just be 1 over 2. Now, there's another way to do this, and that is if you can simplify the fraction inside the radical sign, you can do that, and it makes the question a lot easier. So I'll let you write this down, and I'll show you one other way to do this. Okay, so another way to do this is I know 8 over 32 is the same as the square root of 1 over 4. And again, you're allowed to split up the radicals, so it'll be root 1 over root 4. And then your final answer will just be a half, which actually ends up making this question a lot easier. So root 1 over root 4. And the final answer would just be 1 over 2. Okay, let's do the same thing for this one. Actually, for this one, I'm going to choose not to do what we just did. I'm actually going to split up each one of the radicals. So I'm going to go root 7 over root 49. We can't simplify root 7 anymore, so it remains as is. And then root 49 will just be a whole number 7. There's a reason why I didn't simplify this fraction. When we do the second part of our lesson, it'll make a little bit more sense. Okay, root 12 over root 36. For this one, if you just take a step back from all the radical stuff, you're going to recognize that you can actually take the square root of 36 to give you a whole number 6. So all I'm going to do is I'm going to simplify the root 12, which is going to give me root 4 times root 3 all over 6. Root 4 is just going to be 2 root 3 over 6. Can we simplify this any further? Yeah, we can. The coefficients act like fractions. So 2 over 6 is the same as 1 over 3. And so our final answer is just going to be root 3 over 3. This is pretty straightforward so far. Okay, I see a couple of nods, so I'm going to keep going. Oh, 108 is just such a large number. Is 108 divisible by 6? Because if it is, then this question becomes a lot easier. Let's check. So it's just going to be 18. That's perfect. And the reason why I thought of that is if I have a root 6 at the bottom and I can cross out the roots, it just makes the question so much easier. Okay, so for this question, I am going to simplify this to give me 7, and then 6 times 18, sorry. 6 times 18 is going to give me 108, but I'm actually going to write it as 6 times 18 is the same as 9 times 2 all over root 6. Because when I divided 108 by 6, I got 18, but I know I can split up or simplify 18 to 9 and 2. So you might as well just do all of that in one shot. Okay, now I have a matching pair of root 6s in the numerator and denominator. Those can just cancel out. Root 9 is just the number 3. 7 times 3 is going to be 21 root 2. Am I going too fast or is it okay? It's okay. Okay, let's keep going. For the next one, I can simplify 15 and 27 and simplify them to give me root 3 over root 5. Sorry, root 3 times root 5 over root 3 and root 9. You should be able to cross out the root 3's. The bottom has a root 9, which is going to give me a whole number 3. 3 times 3 is 9. So my final answer is going to be 4 root 5 over 9. Okay, last question on this page. 84 is divisible by, is it divisible by 7? Yes, it is. So 7 times 12. So this is going to be root 7. And I know 12 is root 4 times root 3. Anyone confused as to what I'm doing there? I'm just trying to save a couple of steps. So if you know 7 times 12 is 84, you can also start simplifying the 12 in the same step so that you don't have to write it multiple times. Okay, now the denominator is 15 and root 7. My 7's cross out. Can I simplify the coefficients, 3 and 15? It's like a fraction, so I can reduce this to 1 and a 5. Okay, so just take a look and see if that makes sense. I reduced the 3 and the 15 to give me 1 and 5. I crossed out the 2 root 7s, and the root 4 at the top is going to become a whole number 2. So my final answer is going to be 2 root 3 over 5. Started. Okay,
wait, can you re-explain rationalizing the denominator?
Yeah, sure. So I'll do an example and then we can see if it makes sense. So here we have root 5 over root 2. We have a radical in the denominator. It's not good form. So in order to rationalize the denominator, what you're going to do is you're going to multiply the numerator and the denominator by root 2. So I wrote times root 2 over root 2. Now I'm going to just multiply the stuff in the top and the bottom. So Michelle. Yes, of course. How dare you not like my colors? I understand. Okay, so root 5 times root 2 is going to give us a root 10. And root 2 times root 2 is going to give us a whole number 2. And that is the final answer. Have we changed the value of the question and the answer? We haven't. When you rationalize the denominator, you're multiplying the top and the bottom by the exact same thing. You're not actually changing the actual value. You're just making it into something different. It's kind of like if you have 1 over 2, you can make that into 2 over 4. And the fractions are still the same. They're just written in a different way. So root 5 over root 2 and root 10 over 2 are exactly the same radical. It's just one is in proper form because there's no radical in the denominator. Okay, let's try question number 16. We have root 6 over root 18. You could do this in a bunch of different ways. If you wanted, you could simplify the fraction and make it 1 over root 3, or you can simplify the numerator and denominator separately. Do we have a preference? We could just make this root 1 over 3. And when you write each one of them separately, it's going to be root 1 over root 3 like that. This is not allowed. We're not allowed to have it written like this. So we're going to have to multiply and divide the top and the bottom by root 3. So this is rationalizing the denominator. Root 1 times root 3 is going to give you root 3. Root 3 times root 3 is going to give you a whole number 3. Okay, so again, haven't changed the value, haven't really done anything. You're just changing the form in which it's written. If you have any questions, just stop me, let me know. Or else we're gonna keep going. Okay, question 18. Yes. 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 Honestly, it just makes it easier for me to understand what you're doing when you show that. Okay, so question 18, I see I have a perfect square in the numerator, so I definitely want to change that to a whole number 2. And then I have a 10 and then a root 3. Before I start rationalizing the denominator, can I reduce the fractions? I can. 2 over 10 is the same as 1 over 5. So before I erase, just make sure you know the first step was 2 over 10 root 3. And just because I don't have a lot of space, I'm going to just erase the 2 and the 10, and I'm going to write it as 1 over 5. Okay, but there was a step before this. Hopefully you guys got it down. I'm now going to rationalize the denominator. And this is a question I got a lot in my other class, which was, when I rationalize the denominator, do I need to multiply the top and the bottom by 5 root 3? The answer is no. You don't have to actually include the coefficient. You just need to include the radical. In fact, if you include the coefficient, it just makes the numbers really, really large. So don't. Just multiply it by root 3. Okay, 1 times root 3 will give me root 3. 5 times root 3 times root 3 will be the same as 5 times just a whole number 3. And your final answer is going to be root 3 over 15. Questions? We're okay? Feeling confident? Kind of? Let's try question 20. So question 20, I can't really simplify root 6 because if I did, it wouldn't really give me anything useful. So I'm going to go ahead and rationalize the denominator. I don't need to use the 5. I just need to use the root 6. So I'm going to multiply the top and the bottom by root 6. The numerator will become 2 root 6. The denominator will be 5 times whole number 6. Now, if you wanted, before you multiplied, you can reduce the 2 and the 6, or you can multiply it and reduce it at the end. Whatever you do, the final answer will be root 6 over 15. So if you wanted, you could just reduce this to a 1 and this to a 3, and then you would just have root 6 over 15 as your final answer. Oh, why did I write root 5? Whoops. Okay, go ahead and try 22 and 24, and I will put the answers up as well. You can check your work as you go along. Okay, so for this question,
Wouldn't you cross out the other 3 as well?
nope, when you're reducing, you just choose one thing at the top and one thing at the bottom.
So on the test, they'll be adding, subtracting, simplifying, and then multiplication and division.
Yep. And what we're going to learn tomorrow. For question 2, I chose to simplify first. So I crossed out the 2 root 3s. I rationalized the top and the bottom by root 2s. And then I noticed that in that step over there, I could actually, I don't know what's happening. I could cross out the 2 whole number 2s and just get the final answer. You may have done it a different way. You may have just reduced like the root 3 over 6 to root 2. However you did it, totally fine as long as you get the right answer. So I'm just going to change this to a 2. And then this will become 2 over 5 over 3. You guys, for question number 2, you're going to notice that when we rationalize it, we're going to be multiplying the top and the bottom by root 3. And what I always say is make sure you keep the binomial at the top in brackets. Because if you do that, then you will always remember that that root 3 has to be multiplied to both of the terms in the binomial. And that's really the only difference between what we were doing before and what we're doing now. Okay, so let's try it. 4 times root 3 is just going to be 4 root 3. Can't really do much with that. Minus root 3 times root 3 is going to give us a whole number 3. Over root 3 times root 3 is going to give us a whole number 3. Am I allowed to cross out these 3's? I can't because there's a plus sign, right? You can only cross things out when they're all multiplied together. So this is actually our final answer. However, we are going to do a question where we will have to cross things out. And I don't think it's going to be one of the examples we have. So we'll do one of the other examples, like question number 3, where we had to do that. Let's try question number 4. Before I start solving this question, I'm going to choose to reduce it. So I'm going to have 5 plus root 3. And now you can kind of, do a little bit of this in your head. Root 18 is root 9 times root 2, and root 9 is just 3. So this is going to simplify to give you 3 root 2. To rationalize this, we're going to multiply the top and the bottom by root 2. And we're going to remember to keep the binomial in brackets and distribute that root 2 to every single term. Okay, so we're going to end up with 5 times root 2 root 3 times root 2 is plus root 6. And then 3 times root 2 times root 2, that's just 3 times 2, which is a whole number 6. Why can't I draw a straight line? There we go. And then the 6 disappeared. And that's your final answer. Okay, go ahead and try 6. I'll do it up here. And then we're actually going to do question number 3 together because that's the one with the little trick to it. So I'm just going to erase that so we can do that one together as well. And that'll be the end of that. Okay, so, oh, you're doing this by yourself, right? Root 8 is 4 times 2, so that'll be 4 times 2, that'll be 8 root 2. I skipped a lot of steps there, so just be careful going from 4 root 8 to 8 root 2. Should I show all my work? I'll show all my work. Oh my gosh, this is just not working out for me. Root 2, root 2. Because doing question number 3 leads us to another rule that is pretty important as well. We start off the question in the same way. We're going to multiply the top and the bottom by root 2. Then we end up with 4 root 2 minus 6 times whole number 2 all over whole number 2. So this seems like it's the final answer, but if you were to leave it like this, it's actually not fully simplified. And I'm just going to take us over to the side over here to show you why. Okay, here's just a random question, a random answer, or random whatever. And like I said before, you're not allowed to cross out the 4 and the 32. There's a plus and a minus sign. However, when you have coefficients that are of the same factor, so 8, 4, and 32 are all related, what you have to do is you have to take out a greatest common factor in the numerator. So what that'll look like is, what's the common factor between 8 and 4? 4, right? Another way to think about this is if I gave you 8x minus 4y over 32, and I asked you to reduce this, can you factor out a 4 in the numerator? Yeah, you can. You'll get 2x minus y over 32. And now this is a rational expression, so you're allowed to reduce the 4 and the 32. So in that way, think of the radicals the same way. If I have this question that I've posed over here, I can go ahead and factor out a 4, and I'll be left with 2 root 2, because 4 times 2 is 8, minus root 6, all over 32. Now I can reduce the 4 and the 32 to give me my final answer of 2 root 2 minus root 6 all over 8, and this is simplified. How can you recognize that? Well, whenever you're doing a question like this, always, when you get to your final answer, always look at all the coefficients. If the coefficients all have a factor, a common factor, then you can do this. So we couldn't do this in questions, the ones we did in class, 2, 4, and 6, because none of them had a common coefficient. However, if you look at question 3, we have a 4 and a 6 and a 2. So what can I factor out in the numerator? I can factor out a 2. So I'll get 2 root 2. Oh, I should have multiplied that. 6 times 2 is 12. Oh, actually, if I multiply that, I can factor out a 4. So let me actually go back. Let's keep going with this question. It'll be 4 root 2 minus 12 over 2. Now I can actually factor out a 4 and get root 2 minus 3 over 2. And at this stage, you're allowed to factor out, you're allowed to reduce the 4 and the 2. So your final answer will just be 2 bracket root 2 minus 3. And I'll just highlight the reason why we did this and the reason why we knew to do this. It's because of these numbers over here. And now that you know this, you can go back and look at question number 4. We had a 5, a 1, and a 6 as our coefficients. None of those are common. How about question 6? We had a 5, a negative 1, and a 16. You can't do that. So you have to just look at every single coefficient. If they are common, then you can go ahead and factor them. Now we're done. Fortunately or unfortunately for this homework, because we're skipping all of type 2, you can only do 6 questions for your homework. So go to the first page of your homework. The only questions you are going to be doing are numbers 1, 2, 3, 4, 5, and 6. Okay, so just highlight those. The answers should already be on right.
Do you have any word questions that we could practice?